Hello everyone, welcome to my channel Pragya's Gurukul. Suppose you were given this equation. From its representation, can you guess the physical states of the reactants and products? Can you tell me whether it is an exothermic or an endothermic reaction? Do you notice any evolution of the gas or formation of a precipitate? Does it indicate the necessary conditions for carrying out this reaction? Do you get to know whether it is a reversible or an irreversible reaction? Or are the solutions of the reactants and products dilute or concentrated? The answers to all the above questions is no. Such type of representations are insufficient to represent a chemical reaction completely. In today's video, we are going to discuss how to make a chemical equation more informative. So, let's begin. In order to make a chemical equation more informative, we must mention some information along with it. For that, we use certain specific symbols. Let's learn them one by one. Number one, physical states of the reactants and products. As we all know, they can either exist in the solid, liquid, gaseous, or aqueous state. The specific symbols for the representation of a solid state is small s, for liquid state small l, for gaseous state small g, for aqueous state small aq, all within bracket. I know a question must be popping out into your mind. What is the basic difference between a liquid and an aqueous state? Let me explain it to you. A liquid is a state of matter which has some typical characteristics that distinguish it from the solids and the gaseous. Again, aqua means water. An aqueous solution is a solution or a homogeneous mixture where the solvent is water and the solute can be anything which is dissolved in water. For example, sodium hydroxide normally present in its solid state. When it is heated, it is converted into its liquid state. But when it is dissolved in water, it produces aqueous sodium hydroxide solution. Let's take an example. Solid sodium metal reacts with aqueous hydrochloric acid solution to produce aqueous sodium chloride solution along with the evolution of hydrogen gas. We can represent the equation like this. Sodium in the solid state reacts with hydrochloric acid in the aqueous state to produce sodium chloride in the aqueous state plus H2 in the gaseous state. This is the complete balanced equation for the reaction. Number 2. Formation of precipitate. It is represented either by downward arrow or by simply writing the symbol for the solid state small s. For example, when potassium iodide and lead nitrate solutions are mixed together, a yellow precipitate of lead iodide is produced. The reaction can be represented like this. PbNO3 whole 2 potassium nitrate in the aqueous state which is present in the which is colorless in nature reacts with potassium iodide in the aqueous state which is also colorless to produce lead nitrate which is the precipitate here, or we can write small s which is yellow in color along with the formation of potassium nitrate in the aqueous state. Number 3. Evolution of gas. It can either be represented by an upward arrow or by writing the symbol for gaseous state small g. For example, during photosynthesis, carbon dioxide and water reacts to form glucose with the evolution of oxygen gas. Number 4. Exothermic or endothermic reactions. Let me briefly explain the difference between these two. For exothermic reaction, energy is given out to the surrounding. For endothermic reaction, energy is taken in from the surrounding. Exothermic reaction is represented like this, where we will write R produces the product plus energy. Why? Because energy is given out along with the product. Again, endothermic reaction is represented like this. Reactant plus energy. Why? Because energy is taken in from the surrounding with the reactants so as to form the product. Alternatively, it can be represented like this also. Reactant produces product, delta H is equal to negative. Negative delta means delta H here represents change in the heat or energy. Negative represents the energy is given out. And the endothermic reaction can be represented like R produces P, delta H is positive. For example, during respiration, as we all know that glucose is oxidized to produce carbon dioxide and water along with the evolution of energy that can be used for the cellular activities. This is a chemical reaction that can be represented like this. Glucose C6H12O6 plus O2 produces CO2 plus H2O plus energy. Here, as we know that the energy is stored in the form of ATP. So, in place of energy, we can also write ATP. Now, can you tell me what kind of reaction is it? Correct, it is an exothermic reaction. Photosynthesis. Here, carbon dioxide reacts with water in presence of the energy to produce glucose and oxygen. Now, what kind of a reaction will it be? Yes, it is an endothermic reaction because energy is taken in from the surrounding here. So from these two equations, we can conclude that these are opposite to each other. One is exothermic and another is endothermic in nature. Number 5. Necessary reaction conditions. As we all know, reactions take place under certain conditions of temperature, pressure, catalyst, etc. These conditions are mentioned either above or below the arrow that separates the reactants from the products like this. Here you can either write the word temperature, pressure or catalyst, or if the values of these are given or if the name of the catalyst is given, you can mention here. Temperature can also be written or represented with the help of delta H or delta. Okay. Now, can you tell me what is a catalyst? Yes, a catalyst is a substance that alters the rate of a particular chemical reaction. Alteration means it can either increase or decrease the rate of a chemical reaction. If it increases the rate of a chemical reaction, it is called positive catalyst, and if it decreases the rate of a reaction, it is called negative catalyst. Always remember one thing. Catalysts are chemically unchanged at the end of the reaction. Now, let's take the example of photosynthesis. As we all know, during photosynthesis, carbon dioxide and water reacts together to in presence of sunlight and chlorophyll to produce glucose along with the evolution of oxygen gas. What are the reaction conditions here? Correct, sunlight and chlorophyll. So, the chemical equation for this reaction is represented like this, where sunlight and chlorophyll, which are the necessary reaction conditions, are written on the above and below the arrow mark. Next example is Haber's process. It is the formation of ammonia from nitrogen and hydrogen at 450 degrees Celsius under the temperature of 250 atmosphere in presence of iron catalyst. Now, what are the reaction conditions here? Yes, temperature is 450 degrees Celsius, pressure is 250 atmospheric pressure, and the catalyst is iron. So this will be the representation of Haber's process. Nitrogen in the gaseous state reacts with hydrogen in the gaseous state in presence of iron as catalyst and under 450 degrees Celsius and 250 atmospheric pressure to produce ammonia, which is also in the gaseous state. Number 5, reversible or irreversible. In reversible reaction, the reaction proceeds in both the forward and the backward direction. In the forward reaction, the reactants are converted into the product, and in the backward reactions, the products are again converted back into the reactants. It is represented by double-headed arrow like this. For example, when calcium carbonate in the solid state is heated, it is broken down into calcium oxide, which is also present in the solid state, with the evolution of carbon dioxide gas. Here, the reactant, which is calcium oxide, is converted into the product in the forward reaction, that is calcium oxide and carbon dioxide, and in the backward reaction, calcium oxide and carbon dioxide combine together to form the calcium carbonate again. Okay, so this is an example of irreversible reaction. Irreversible reaction. Here, it proceeds only in the forward direction and is represented by a single-headed arrow. For example, the formation of slaked lime from the quicklime is an irreversible reaction. Similarly, the formation of rust from iron in presence of oxygen and water is also an irreversible reaction. Why? Because from these two products, that means from slaked lime, you cannot get back the quicklime and water again, and from rust, you cannot get back iron and oxygen and water again. We can see from this diagram or picture that the reaction between carbon dioxide and water to produce glucose and oxygen is a reversible reaction. The forward reaction is called photosynthesis and the backward reaction is called cellular respiration. Number 6. Concentrated or dilute solution. As we all know, in solutions, there are two parts. One is solvent and one is solute. The solvent is the substance that exists in greater quantity and the solute is present in lesser quantity, isn't it? Now, the concentrated solutions are those solutions in which large amount of solute is present. It is not necessary that this amount of solute will be greater than the solvent. Okay. And in case of dilute solution, the solution contains smaller amount of the solute as compared to the solvent. For example, dilute is represented by DIL within bracket and concentrated is represented by CON within bracket. If you are given this reaction, what will it signify? Yes, it will signify that zinc in the solid state reacts with the sulfuric acid solution, which is an aqueous solution, isn't it? In the concentrated state to produce zinc sulfate in the aqueous state along with the formation of sulfur dioxide gas and water in the liquid state. Hope this video is helpful for you. Please subscribe to my channel and press the bell icon for further